I'm now going to do some examples of actually using the distance formula and show you another method of finding the distance between 2 points on a coordinate plane. The first example I'm going to do is I'm going to try to find the distance between the point 3, 2 and the point 4, -1 on the coordinate plane. So I want to find the distance between 3, 2 and 4, -1 on the coordinate plane. So I want to find that distance. Well, one method of finding the distance is to use the distance formula. So I'm left the distance formula from where we derived it, and the distance is equal to the second x-coordinate, which is 4, minus the first x-coordinate, which is 3, quantity squared, plus the second y-coordinate, which is -1, minus the first y-coordinate, which is 2, quantity squared. Follow my order of operations. 4 minus 3 is 1. -1 minus 3 is -3. And I get 1 squared, which is 1. -3 squared, which is 9. And 1 plus 9 is 10. So the distance is the square root of 10. So if you memorize the distance formula, you just substitute in the values for x, for your second x, your first x, your second y, your first y, and you go down until you have your answer. In this class, we will provide exact answers, and if you can simplify what's underneath the radical, you'd go ahead and simplify what's underneath the radical. We won't put any of this stuff into the calculator unless we ask for an approximate answer. So I'm going to show you another method to do the exact same problem without having to memorize the distance formula. Between any 2 points that are not vertical or horizontal from each other, I can draw a right triangle. And the way I think about this is I want to know the distance between here and here. Well, the distance between 2 and 3 is 1. I also want to know the distance between here and here. The distance between 2 and -1 is 3. And I just set it up, and I'm just going to immediately write down the square root of 1 squared plus 3 squared, which is the square root of 10. I get the exact same answer. I'm doing the exact same math that the distance formula does, but I'm not actually substituting the values in the distance formula. Many students see all of these letters and all the parentheses and stuff like that, and it shuts them down. You don't need to do the distance, have that memorized if you remember what the Pythagorean theorem is. I'm going to do 2 more examples. First example I'm going to do is homework problem 17 from page 57. I want to know the distance between -2 and 6 and the point -2, 6 and the point 3, -6. So I'm going to show you how I would do it without actually plotting the points. So what I do is I write the 2 coordinates that I want to find the distance between. And then all I do is I ask myself, well, how far is it between those 2 numbers? Well, the distance between -2 and 3 is 5, so I write 5 squared. And the distance between 6 and -6 is 12, so I write down 12 squared. Put it all underneath the square root sign. That's 25 plus 144, which is the square root of 169, which is 13. So without plotting any points, you can get your answer. The second example I'm going to do is homework problem 18 from page 57. And I want to know the distance between the point 8, 5 and the point 0, 20. Just like the last example, I write down my 2 points, 8, 5, and then 0, 20. And I ask myself how far it is between on the x distance. Well, that's 8. So I'm going to write 8 squared. Distance between 5 and 20 is 15. So I'm going to write down 15 squared. That gives me 64 plus 225, which is 289. And if you had me for Algebra 2, that would be a memorized perfect square, and that would be 17.